Welcome back everyone. Today we're going to do a topic on ADA video assignment, which is insertion sort with time efficiency. Introduction. Insertion sort is a simple sorting algorithm that works by iteratively inserting each element of an unsorted list into its correct position in a sorted portion of the list. It is a stable sorting algorithm, meaning that elements with equal values maintain their relative order in the sorted output. Insertion sort is like sorting playing cards in your hand. You split the cards into two groups, the sorted cards and the unsorted cards. Then you pick a card from the unsorted group and put it in the right place in the sorted group. Insertion sort algorithm. Insertion sort is a simple sorting algorithm that works by building a sorted array one element at a time. It is considered an in-place sorting algorithm, meaning it doesn't require any additional memory space beyond the original array. To achieve insertion sort, follow these steps. We have to start with the second element of the array, as first element in the array is assumed to be sorted. Compare second element with the first element, then swap them. Move to the third element and compare it with the second element, then the first element, and swap as necessary to put it in the correct position among the first three elements. Continue this process comparing each element with the ones before it and swapping as needed to place it in the correct position among the sorted elements. Repeat until the entire array is sorted. We're going to take this example with the numbers 23, 1, 10, 5 and 2 to place it in a proper order, which will be 1, 2, 5, 10, 23. Let's see how this is achieved. In the 23, the first element in the array is 1 with 23, and the current element becomes smaller instead of 23. So the sorted part will be 1, 23. The third one, compare 10 with 1 and 23. Since 10 is greater than 1 and smaller than 23, insert 10 between 1 and 23. The sorted part until second index is 1, 10, 23. In the fourth pass, we compare 5 with 1, 10 and 23. Since 5 is greater than 1, smaller than 10, you insert 5 between 1 and 10. In the fifth pass, we compare 2 with the rest of the elements. Since 2 is greater than 1, we insert 2 between 1 and 5. The sorted part until the fourth index is 1, 2, 5, 10, 23, which is also the final array. Here's a diagram to understand and implement insertion sort. An explanation. The insertion sort function takes an integer array AR and it is size n as input parameters and sorts the array in ascending order using the insertion sort algorithm. The outer loop iterates through each element of the array except the first one. For each element at index I, the inner loop, which is while loop, compares the element with the elements before it and moves the larger elements one position ahead to make space for the current elements. The time complexity of the insertion algorithm is O n to the square. In the worst case scenario where n is the number of elements in the array. This is because in the worst case, each element has to be compared and possibly moved to its correct position. However, in the best case scenario, when the array is already sorted, the time complexity reduces to O to n, as there are no elements that need to be moved within the inner loop. This implementation of insertion sort is done in place, meaning it sorts the array without using additional memory proportional to the input size. Therefore, its space complexity is O of 1. Insertion sort time complexity. The best case, the average case, and the worst case. O of n if the list is already sorted, where n is the number of elements in the list. O of n square if the list is randomly ordered. O of n square if the list is in the reverse order. Advantages versus disadvantages. Advantages of insertion sort. It is simple and easy to implement. It is stable sorting algorithm, efficient for small list and neatly sorted list, space efficient. The disadvantages of insertion sort. Inefficient for larger lists, not as efficient as other sorting algorithms like merge sort, quick sort for most cases. Thank you.